Hey everyone, Jonas Engelbrecht here and welcome to day 3 of the Instruments training module. So what we're going to cover in this training module is we're going to look at the design and the operation of the EFIS, and then the design and operation of the FMS, and then the design and operation of the FD or the Flight Director, right? So that's the Electronic Flight Information System, that's the first one, the EFIS. And then we'll look at the Flight Management System, that's like the brain of the aircraft, right? The FMS, and then we'll look at the Flight Director or the FD. So the FMS and the FD is all part of the EFIS, right? It's like two components of the EFIS, but there are quite a few things to cover when it comes to the FMS and the Flight Director. So I've decided, to make those two things topics by themselves. So we'll discuss the EFIS, that's the overview of the whole system, and then we'll go into detail into the micro when we look at the FMS and the Flight Director system. So let's start off by looking at the Electronic Flight Instrument System, that's called the EFIS. So what is it? That's the big question, right? Well, an EFIS is just a sophisticated system which shows flight information on an electronic screen. It gives the same or more information than the old type of instruments found in the cockpit. So guys, this is just like a very advanced instrument panel, right? So instead of having, we call it steam dials, instead of having the altimeter and the AH and the DI and your airspeed indicator and all these things as separate instruments, it's now all just shown on one screen. That is called the Electronic Flight Instrument System. Now obviously it's not just the instruments. There are a lot of different components that forms part of the Electronic Flight Instrument System, right? But I want you to see it as a new generation thing. It's like all on screens and it's very modernized, if you want to call it that, right? So it's much more efficient and reliable compared to the old instruments, right? So all the information found on the old instruments is now been integrated into a single presentation which is easily understood using color symbols. So instead of having, to scan your AH, your airspeed indicator, your altimeter, your DI, your vertical speed indicator, all these different instruments, and they are obviously in different places in the cockpit as well. So instead of having to scan all of them, you now have all of them displayed very close to each other just on one single screen, right? So your eyes have to move only little bits and pieces when you want to scan all your instruments. Instead of having to move it through a big part in the cockpit, all of them are now just on one screen. So it's much more efficient. It helps the pilot a lot with his scanning technique, obviously, as you can imagine, right? So this presentation of all information on one single screen is placed in line of sight, which reduces the scan required for a large instrument panel. So instead of having a huge instrument panel, with all your different RPM parameters and your oil temperatures and oil pressures and all these things, scattered all over the cockpit, now it's all integrated basically into one screen. So obviously you'll have different screens for your engine parameters and for your air data, like your airspeed and your altitude and your attitude, but the principle stays the same. All your air data will be on one screen and it will be incorporated on one screen close to each other, and all your engine systems and flap systems and undercarriage systems and all of those things, basically the aircraft systems, will also be shown on a separate screen. It depends on the aircraft type and it changes from manufacturer to manufacturer, and also obviously depends on the type of avionics that you've got, but that's how they are typically split. It's typically split into your air data like airspeed, altimeter, your AH and all of that, and then another screen has got all your engine parameters, your flap settings, whether your gear is down or not, all those things, right? So as you can imagine, it really helps with the scanning technique, right? So if you're going to be doing IFR flying, it can be quite fatigueful to having to look at lots of different instrumentation. So now that you have everything in one single screen, it just makes it so much easier and much more convenient, and also obviously at the end of the day, it helps with the pilot fatigue so you don't get so tired, and it makes the flight safer at the end of the day, right? That's why they have built the EFIS system, the Electronic Flight Instrument System. And there is a very good example of one. This is actually the Pilatus PC24, and it's got a Honeywell system, right? So you can see over here, this is what we call the PFD. This is called the Primary Flight Display. And then it's actually got two MFDs, right? The multifunction display and another multifunction display. And then this is also a PFD. Now, guys, it all depends on the aircraft type, right? These things can be shown like all four screens can be in a row, or you might have 2 or 3 screens on this side and 3 screens on this side. It all changes from aircraft type to aircraft type. It depends on how much space there is in the cockpit, and also the type of manufacturer that's making the avionics. Like for instance, the Pilatus has got the Honeywell avionics, right? And so you can see on the primary flight display over here, there you can, I don't know if you can see it properly, but you can roughly see there's your airspeed on that side, there's your altitude on that side, there's the vertical speed indicator. You've got a few of your instrument or your engine parameters over here. Then you've got your radio frequencies and your nav frequencies for like your VOR stations and so on. And then also on that same screen, you've actually got your HSI, okay, your horizontal situation indicator. Now, you will see that once again, this changes from aircraft type to aircraft type. Sometimes they just give this top part with the airspeed and the attitude of the aircraft and the altimeter and the VSI. Sometimes they give that as one screen, and then the HSI is a screen by itself, right? So it can be split into 2. So the little bit older systems has got them split into 2, but as the aircraft becomes newer and newer, then they actually integrate them both into one PFD. And then on your MFD, or this is also called so this can be called your ADI, your attitude director indicator, right? That shows you your attitude. As you can see, it's on the PFD screen. So some books might talk about attitude director indicator, some books might talk about your PFD. It's at the end of the day the same thing over here, okay? And then this over here can be called the MFD, a multifunction display, or it can be called a ND, a navigation display, right? November Delta. Now, once again, you can see that these 2 screens are actually providing you with different types of information. The top one in this case is providing you with a map, right? And it will most probably show your track and your flight plan over there. And then at the bottom screen, you've got all your systems, right? So you can see the flaps, the fuel systems, and some pressure and your fuel flow, tire pressures, and your your engine parameters and all these things. So these are all the systems with the aircraft. It's basically a view of the aircraft from the top with the 2 engines sitting there, right? And obviously hydraulic systems as well will be shown there. So once again, this can change from manufacturer to manufacturer, but the basic stays the same. It's a MFD or a ND, a multifunction display or a navigation display. And then on this side, you've got once again your PFD, and the information over here and over here is obviously basically the same. Depending on how you've set it up, you can change this side to show you not a HSI, but let's say a half HSI, or it can show you the terrain map, or whatever the case. You've got a few functions here on the side which you can change it to, and this is called the MCP, and I will show you guys this. It's called the mode control panel, right? And the mode control panel is basically the panel that you use to change the settings on the ADI, on the attitude director indicator. So you can take away the synthetic vision or whatever the case might be, and you can change the HSI into just half a HSI, or you can see terrain map there, or something like that. Depends on what functions obviously the system has, right? So that's basically in a nutshell what we're going to cover, and this is a very good example of an EFIS system, right? Now if I could choose, I would definitely want to fly in an aircraft like this compared to an aircraft like this, right? Can you imagine your scanning techniques and the amount of workload that goes into flying an airplane like this, right? And you can see this airplane's got 6 engines, and if you know a little bit about aircraft, you'll notice that this is the Antonov 225, right? So it's that huge Russian-built cargo airliner, and you can see it's got very old technology. Although it's got a few screens there, it's got a screen there, and then it's got a HSI and your normal AH over there. You can see it's all gyroscopic instruments, right? So can you imagine the scanning techniques, having to go all between these instruments? Then you've got a panel here in the middle, you've got some lights and things here at the top, and all your throttle settings and your flaps and everything. There's a lot going on in this cockpit, right? And then you've even got some things here on the side, right? So you can see it's not as clean as this cockpit over here. And this was just the evolution of aircraft and the evolution of aviation safety, right? The more technology advances, obviously, the more we want to start working towards, getting the cockpit cleaner and easier to operate and safer as well, right? Because to be honest with you, this cockpit over here is not as safe as this cockpit over here, right? So as you can imagine, if you fly 10 hours in this aircraft and you fly 10 hours in this aircraft, you're going to be really tired in this aircraft, right? You most probably fall asleep after 5 hours anyway. So let's have a look at the EFIS architecture. So this is like an overview, guys, of what's going on behind the scenes, let's call it that, right? And so just to give you the basic picture, so this over here is your pilot instrument panel, right? So this is what you see inside the aircraft, okay? And this is the captain side, or the let's call it the left-hand seat side, and this is the right-hand seat side, right? So let me go one back. It's basically like this, left-hand seat and right-hand seat. But now you'll see that these two screens are actually broken up into two, right? And I've done this for a reason, because most of the notes and things will talk about two different or two separate screens, right? So the top screen is called your ADI or your PFD, like I've shown you, and that stands for Attitude Directory Indicator, or your primary flight display. And then the bottom screen is your HSI, or your navigation display, so horizontal situation indicator or your navigation display. Now, this is basically what you see over here with the blue box and the green box is basically what you see in this cockpit. But just imagine this screen over here being divided into two parts. So you just have your attitude there at the top, and then at the bottom you've got your HSI, right? And forget about these screens over here. Okay, so basically what you see over here is just our PFD over here split into two, right? So sometimes in the older generation avionics, you get this top part as your attitude directory indicator and the bottom part over here as your navigation display and your HSI, right? And like I've said to you, as technology has evolved, they've started putting everything together, right? So this is a little bit older type system here. So you've got your one screen for the ADI or PFD, and then the other for the ND, and then on the co-pilot side as well, you've got the HSI or the ND, and then the attitude directory indicator or the PFD on the right hand side as well. And then between them, you've got what we call a remote light sensor. Now a remote light sensor, guys, is just like a little sensor, and this thing senses how much light is in the cockpit. So it's a light sensor switch, and the more the brightness in the cockpit increases, so the more sunlight there is, the brighter the displays become, right? So the aircraft can basically pick up when it needs to make the screens brighter or when it needs to dim the screen. So let's say you take off early morning, right? So when it's still dark, obviously the remote light sensor switch is going to see that it's going to notice it's dark outside, right? There won't be a lot of light in the cockpit. So the screens would be quite dimmed, right? But now as you start flying and daylight starts breaking, the remote light sensor switch will start getting more light, and then it would actually start increasing the brightness of these four screens, right? Now obviously there would be a manual selection as well, so you can manually change the brightness as well, but that's the function of the remote light sensor switch. Okay, and then if we move down from these, we've basically at the bottom got three generators. Now these are called symbol generators. So you've got a left symbol generator, a center symbol generator, and a right symbol generator. Okay, and we'll talk about those and what their functions are just now in a lot of detail. But as you can imagine, you are getting inputs from certain instruments and from certain air data, like your airspeed indicator, your VOR instruments, your weather radar maybe, your ILS instruments, all these different things, right? And all that information gets sent to a symbol generator, because remember, these screens are electronic screens, right? So you can't have a gyroscope spinning on an electronic screen. So the information is being drawn from, we call it inputs, but the information is being drawn from your different sources of information, like your VOR and so on, and then it gets sent to a symbol generator. So on the left hand side, for instance, this would be VOR1, your weather radar, and LOC1, meaning localizer 1. So this is like just a function of the VOR, right? That's if you fly an ILS. And also LIRS is left inertial reference system. Now this is a very advanced navigation system that basically works with 3 different gyroscopes. You don't have to know too much about that for now. But this basically tells the aircraft where it is, on the Earth's surface. Not on the Earth's surface, but where it is, in terms of coordinates. And then this information gets sent to a symbol generator. And this symbol generator is then responsible for taking this information and putting it into a symbol, right? And that symbol then gets sent to either the HSI or the PFD or the ADI, right? So from this information, it goes through the symbol generator, and then it gets sent to your HSI, your VOR information over there, and your attitude and your speed and your altitude information gets sent over there, right? Now, as part of the symbol generator, you have an ADI and an HSI connection here as well. Now, this is just a control panel. So what I mean with a control panel, if I go back here, remember I mentioned to you, you've got these little buttons here on the side where you can change the HSI into like a half HSI, or you can maybe insert a little map there, so they can take this map over here and insert it there, and then you don't see your HSI. So you can just change, let's call it the layout and the setting on the screen over there. So that is what this control panel does, right? You can change the ADI settings for the PFD, and you can also change the HSI settings for the ND, or the navigation display. And the same goes for the co-pilot, right? So you have 3 symbol generators. Why do we have 3? Well, the pilot on the left needs to have his own one. The pilot on the right needs to have his own one because he's using the right inertial reference system, the VOR number 2, not VOR number 1. He's using the same weather radar most probably, and then he uses lock 2 and not lock 1. So he uses a different VOR. So he gets information from different sources, right? So obviously you would, sometimes have your VORs on the same frequencies. That doesn't matter. It just needs to go to a different symbol generator, because if everything is running through here, then you won't be able to pick up if this thing is making a mistake, because the information gets sent to these screens over here, and then it would get sent to these 2 screens on the right. And then if these screens are compared, well, they will obviously be the same because all the information comes from one symbol generator, right? So that's why we have the right symbol generator, and that is then connected to your right-hand HSI or ND and your right-hand ADI or PFD, okay? And then you've got an alternate selector over here, which is the center symbol generator. Now, what I mean with alternate selector switches, this just means that if you see, or if the aircraft tells you that, there is an issue on either of these symbol generators, okay, the aircraft will pick up an issue. Then you have a selector switch where you can say you want to use this central symbol generator. Typically, very advanced aircraft like the PC-24 over here, it does it by itself. It automatically changes to the central symbol generator. The little bit older aircraft, you can still select, that you want to change to the central symbol generator. Now, this is all part of the training that you do on the aircraft, obviously, right? So you don't have to worry about how does it work and all of that. It's type specific. Every aircraft is basically different. But the central symbol generator gets information from the center IRS, from VOR3, same weather radar, and then from lock 1 and lock 2. So it gets information from this side and from this side. So what happens over here is, if this symbol generator was, to bomb out and not work anymore, well, then the pilot on the left-hand side can either select, with a selector switch to use the central symbol generator, or if the aircraft does it automatically, well, then it will switch over to the center symbol generator by itself, right? So that won't be an issue. That can happen automatically, okay? But the central symbol generator is just there as a backup. So guys, this is how it works. The information comes from your instruments like airspeed and all of that. That goes into a generator, a symbol generator, and from there it gets sent to your screens, right? If you know that, then you already know a lot, right? You need to understand the overview and the architecture of the EFIS system. So now let's see. The EFIS system is also interlinked with other systems. So it can be interlinked with multiple avionics, radios, and also navigation equipment, right? So you like your VOR or a GPS or something like that. And it can also be linked with a thrust management control system and the automatic flight control system. So that whole system that you've seen, this whole system over here, as you've seen, it's just been getting, I've just shown you inputs from like a VOR instrument, from an inertial reference system, which is like a navigation system, that knows where you are at all times. But this system can also be linked, with an autopilot, and with lots of different radios, right? So if you've got like 3 or 4 different sets of radios in the aircraft, they can be linked over here with this, whole architecture over here. And also things like the thrust management control system. Now, this is something that's obviously really advanced, right? It's usually your bigger aircraft that's got these. And the thrust management control system is a system that can basically control the aircraft power settings for you. So the throttles move automatically, right? So if you tell the aircraft, for instance, fly at 120 knots, and you put the thrust management control system on, well, then the aircraft would adjust the thrust automatically and it will fly 120 knots for you, right? So typically that is in your bigger aircraft, as you can imagine, because that really makes flying very economical and very smooth as well, right? Because the computer is much quicker than a human can ever be, right? So then the flight management system. Now this is where everybody gets confused. They start becoming they become confused, when they see EFIS and then FMS, right? So what is a flight management system, or what is a FMS? Now the EFIS can also be linked with a FMS, which provides flight progress and map displays to the pilots. So guys, the FMS is something completely separate from the EFIS, but it can be linked to the EFIS. So the EFIS is this big architecture that you've seen over there, and the FMS, for instance, would be a system that just gets linked, to the symbol generators. And the FMS is a system, and we'll talk about it just now, but the FMS is a system that acts like the brain of the aircraft. You tell this system that you want to be, at 10 nautical miles from a certain airport, you want to be at 5,000 foot, and then it will do all the calculations for you, and if you put the autopilot on, it will actually get you at 5,000 foot, 10 nautical miles from that airport, right? So that's what the FMS does. So the EFIS is just this system over here, and the FMS is like the brain of the aircraft connected, to these things. This is not the brain of the aircraft. This is purely just an information system, right? It just displays information to you. That's all it is. There's no brain or, processes or mathematical equations or anything like that involved when it comes to the EFIS system. Okay, that's important to understand. So let's have a look at the FMS, right? Now, the reason why I wanted to show you this picture, let me just see here. So the EFIS can also be linked to the FMS, which provides flight progress and map displays to the pilot. So the first thing that I want to talk about are these three symbol generators. Okay, so we'll talk about the FMS a little bit later. I'm going to go into a lot of detail there. The first thing I want to do is talk about, all the different little details that you see in this architectural system over here, right? We've basically already covered it, so I'll just go through it quickly. So what are the symbol generators doing, right? And you've seen over here, we've got three of them, left, center, and right. So they are responsible for creating the symbols, and it gets inputs from various aircraft sensors and avionic equipment, and the data is then processed and converted into suitable data for the representation of the, on the ADI or the HSI, right? So it gets information from different sources, and then it takes that information and it just changes that information into a symbol, right, which you can see on an electronic screen. Now, faults, obviously, this is electronic things, right? It's like any software, they can have faults. And displays can be interrupted when faults occur. So they can actually be like a red cross across the display, right? So if the system picks up that there's a fault, it can put a red cross across the display. And why can these things have faults, or what can they be? Well, it can be things like over temperature of the screen. So if the screen becomes too hot, right, then it will most probably just go off and black out. Or it can tell you as well this screen is reaching its maximum temperature limit or something like that. It can be because of power failure. It can be because of unreliable information from the sources, or failure of the aeroplane equipment, right? So let me give you a good example of this. Let's say you're busy flying at a certain speed, let's say 120 knots, right? And suddenly the pitot tube gets blocked. Well, the screen is not going to continue showing you 120 knots if it knows that the screen is blocked. If it knows that the pitot is blocked, right? So if it knows that the pitot is blocked, or if the screen sees that it's getting unreliable information, then it would actually just put a cross across your airspeed, right? It will most probably still display it, but it would put a cross across it so that you can see that there's something wrong here. Okay, and that is what we mean with a fault. So the symbol generator can actually, produce a fault as well. It can tell you when something is not right. Now, we also have what we call an instrument comparator unit, or ICU. It's not the place that you go to when you've had an accident. This is a different ICU. So this is a unit that constantly monitors the display for disagreement. Okay, so it's a comparator unit, right? The word gives it away. So it compares the left screens and the right screens. So what is compared? Well, attitude is compared, and then heading or track is also compared. So when it is outside perimeters, so let's say on the left hand side, it's showing that you're flying on a heading of 360 degrees, and then on the right hand side, the PFD is showing that you're flying on a heading of 010. So that's like a 10 degrees difference. Now that's quite a lot. Usually the EFIS systems are set to a maximum of either 3 or 5 degrees difference. Any more than that, then it will start warning you. Okay, so if it sees that there's a difference between the two, if it compares these two and it sees that it's outside the perimeters, then a master warning light will illuminate and an oral signal sounds. Now, what is a master warning light? It's just like a warning light inside the aircraft that says warning, right? And it's typically across the screen. So I'll go back here and show you where it is. So this one is over here. So typically there would be a red light that comes on warning, and you can actually push to reset it. And then at the bottom there will be an amber light or an orange light that comes on that says caution, right? And the same on the co-pilot side. So warning and caution, or warning and caution, right? So if there's an issue with the, with the displays, or the system picks up that, the information that it's getting has got an issue, and it compares the information, well, then it can, illuminate either the warning light or the caution light, and it will tell you on the screen heading with a question mark, or heading unreliable, something like that, depending on the aircraft type that you're flying. Once again, it's different from aircraft to aircraft. Okay, so it's continuously monitored, and that is the instrument comparator unit, right? So the light will illuminate and an oral signal sound. So the aircraft might tell you, heading unreliable, a voice saying heading unreliable or something like that. And now the big thing is that you need to remember that the instrument comparator unit is inhibited when the central symbol generator is being used by both pilots. Now inhibited, it means that it's not working. Right? I know that word also took me quite a while to understand. So if you're not familiar with that word, it just means it's being put off, right? Inhibited is just a fancy word for off. So it's off when the central symbol generator is being used by both the pilots, right? So let me just go back. So if both the pilots, if this pilot and this pilot uses the central symbol generator, as you can imagine, the comparator unit won't be able to compare this and this, because it gets its symbols from the same symbol generator, right? So then the ICU will not be working. Okay, that's really important to remember. Okay, so there we can see. So it basically just compares this one and that one, and it compares this one and this one, right? So this might, for instance, say you're pitching 5 degrees up. If this one says no, you're pitching 10 degrees up, well, then there's going to be an issue, right? So then you will get a warning and also a sound, right, that says pitch unreliable or something like that, right? And the same goes for the bottom screen. So the navigation or the HSI display on the left, and the navigation or the HSI display on the right hand side. That is the ICU. Now you'll also maybe read something that's called compression mode, right? Or you might have heard of this. What is compression mode? Well, this is when the EFIS just compresses the screen. Okay, so if the ADI or the HSI screen fails, then on most EFIS systems, the remaining CRT, that's a cathode ray tube, or the LED, the light emission diode. Now this is just the screen, guys, so you get 2 different screens, and there's actually a reason why I've put those 2 abbreviations in there. The CRT or the LED, if you read that, it just means screen. CRT is a cathode ray tube. That's a very old type of screen, and the LED, it's a light emitting diode. That's also a screen, but it's a more new generation type of screen. Okay, so if you read CRT or LED, just read it as screen. So on most EFIS systems, the remaining screen will be automatically compressed with the information of both the screens. And I've got an example here for you. So this is in the PC-12, for instance. Now, if you look at the PFD over here, you can see you've got your information there on your attitude, your speed, your altitude, and then you've got your HSI there. And then you've got the map over here with your flight plan, and you've got your systems over here, right? Your pressurization system, electrical system, trimming, wheels, flaps, and then your fuel over here. Now what happens is, compression mode is when you lose this screen, for instance, or let's say you lose both of these screens, right? Both the MFDs is for some other reason gone, right? What it can do is, it can take this PFD and it can go into compression mode. So instead of showing you the engine parameters there like it is, and all the radios over there, it will take some of this information and show it on here. So it will throw away some of the radio information and some of the engine information, and it will show you some of the systems information on this screen over here. So it just rearranges the screen, that it can show you all the important information on one screen, because you've lost these 2 screens. I would rather see whether my gear is down instead of seeing all my radio frequencies, right? 1 or 2 radio frequencies is enough. You don't need to see all 4 of them, right? So that's why they follow that approach. That's called compression mode. Now let's talk about the mode control panel, and I've mentioned this to you a little bit earlier as well, the MCP. So the mode control panel, I'll go one back, and the mode control panel on the PC-12 is typically on the side over here and on the side over there, and this is also a mode control panel over here, right? So you've got a few settings that you can play with here on the sides and then over here as well. And the only thing that why you've got this thing is, you know, to change the information on here. You might not want to see, like you can see over here, there's terrain displaying there now. You might not want to see that, right? You might want to have your VOR, you know, not overlaid with terrain. Then you must be able to take it off, right? So that's what the mode control panel does. So it controls the ADI and the HSI information displayed. So the MCP is the panel that is used to change between different information on the ADI and the HSI. So you can either change your your HSI into a full HSI or into an expanded HSI, whatever the case might be, depending on what you feel comfortable to fly with. And the pilot can decide what he or she wants to see when, right? So the MCP gives you the opportunity to select how you want to see information and how the information is displayed by the SG. So once again, it comes down to the same thing. You can just pick how you want to see your information with using the MCP panel. And it's basically different folks, you know, like different strokes, right? So every pilot has his or her own preference, although there are SOPs in some companies that tells you how to use it. So in some companies, they've got standard operating procedures that say, you know, you have to have the full HSI when you are taking off, or you have to have the full HSI when you're landing, or whatever the case might be. And then obviously there would be checklists for that, right? That's not part of the syllabus, it's just something interesting. Okay, and this is an example of a mode control panel. Now guys, I don't want you to get confused here, and this is specifically why I've shown you this whole thing. The right hand side of this is actually all your autopilot functions, okay? And later we're going to talk about all of this as well, but you can see all your autopilot functions are over here. Flight level change mode, heading mode, VNAV mode, LNAV mode, thrust mode, speed mode, vertical speed mode, altitude hold, and then approach and lock mode, and then here's your engagement modes, and then your disengage button, right? Now this side over here is actually the mode control panel, and once again this changes from aircraft to aircraft. This is a Boeing 747's mode control panel, okay? So obviously they have screens that look different to the PC-12s or to the PC-24s, or you know, to actually to a 737 as well. So it changes even for the same manufacturer. But the mode control panel gives you the opportunity to change the information that you see on your screens. And over here, for instance, you can see you can pick between approach, VOR, map, or plan, right? These are the four options that you have. And then this over here gives you the option of, I think this is the range, okay? So 10 nautical miles, 20 nautical miles, 40, 80. So this is how much the map is zoomed in and how much it is zoomed out, right? And then you also have your baro settings. You can pick whether it can be in inches or mercury or hectopascals. That's obviously nice, because if you fly in the States, you need to fly inches. If you fly, you know, somewhere else, it must be inches, hectopascals. And you know, then you can set your DH and your MDA. That's something we're going to talk about. And there are a few other buttons here as well, right? Weather, station, waypoints. So if you press this WPT, it gives you different waypoint information, like the coordinates or the name of the waypoints or whatever. So if you click the waypoint, for instance, on the screen, it might show you the waypoints. If you click the waypoint again, it will take away all the waypoints, right? And then the same with airports. So if you press this button, it will start showing all the airports that is within, you know, the range that you have selected over here. Now obviously a map can become really cluttered, right? I mean, if you fly in Europe or in the States, then you know there are a huge amount of airports in a very small area. So you don't want to necessarily be flying with this, and this is what gives you the option to take it off, right? That's why you have the mode control panel. And then there's some other ones, data and then position, right? So this is the MCP. This is an example of an MCP that can be used, you know, to change the information on your different displays. And here's the perfect example of where a screen is split. And this is actually just an old type of PC-12, right? So here's the ADI. You can see you've just got your attitude information here, right? You can see there's the aircraft, there's the blue part, and the green part that you see is called the flight director, or the FD, and we'll talk about that. And then the bottom screen is your HSI or your ND, your horizontal situation indicator, or your navigation display, right? And you can see your airspeed indicator, your altimeter, and all these things are still old school, you know, steam dials, right? So they are still operating, you know, on the old-fashioned way. There's no EFIS really incorporated in there. So this is the example that I've shown you, you know, really right in the beginning of this video when I showed you the architecture of the EFIS. This is what I was referring to, right? So obviously with the mode control panel, you can change the settings on here if you want to. And where you actually use it the most is to change the settings on here, right? If you want to go into a plan mode to show your flight plan, or to show you a map instead of the VOR, or to take some of the information that is displayed on the side here away, you might want to have DME and not ETA, or you might want to have the VOR2 and not VOR1, or whatever the case might be, right? I'm sure you get my point. So let's talk about the ADI. Now this is basically the PFD. This is the top one, right? It's this guy over here, right? So PFD, primary flight display, or ADI. So provides information. The ADI provides information on the attitude. The flight director commands the localizer and glide slope deviations, and then airspeed deviations as well, right? Now as you can see over here, it doesn't really. Okay, it's split in here. So you've got the airspeed indicator by itself, and then you've got your attitude director indicator by itself, and then the altimeter by itself. But like you've seen, in the new generation avionics, these are all combined. It's all on one screen over here. Okay, so it can the ADI shows you all these different variations of airspeed and your VOR needles and all these things. Now, what is the flight director? I keep on talking about the flight director. Now, this is the wings or the crosses that you see on the ADI. It is a system that shows you where to move the aircraft to get the results that you have selected. So let me give you an example. Let's say you have selected a pitch of 10 degrees. Okay, so what you do is you would go to this control panel over here. Okay, and you can go and pick. I've taken 10 degrees pitch now, but let's say vertical speed. Let's say you want to climb at 500 foot a minute. Then you would press vertical speed here on the autopilot control panel. Remember guys, the autopilot is not on yet. You're only picking a mode here, and I'll talk about all the functions of the autopilot when we talk about the autopilot. This is just going to be a quick one. So let's say you press vertical speed here, then you take this little scroller over here and you set it to 500 foot, right? So it will most probably be plus 500 foot, which shows that you want to climb at 500 foot a minute. Now, when you tell the aircraft that you want to climb at 500 foot a minute, if the flight director is on, and there you can see you can select it, FD on, right? If the flight director is on, the flight director will move into a position that shows you where you must put the nose of the aircraft to climb at 500 foot a minute. Because you've told the aircraft, I want to climb at 500 foot a minute. You've put the flight director on. Now it's going to show you what must you do with the aircraft to climb at 500 foot a minute. And as you can imagine, you can do the same with heading. So let's say you want to turn on to, let's say you're on a heading of, in this case it is, okay, let's say you were on a heading of 310. And now you took this knob and you turned it to a heading of 319. So obviously you want to turn right. If you have selected heading mode here and you've set heading 319 there, and the flight director is on, well, the flight director is going to bank its wings to the right to show you, hey, you must turn to the right to turn onto this heading of 319. That's what the flight director does, okay? And like I've shown you, the flight director is that little green guy there. Once again, this changes from aircraft to aircraft, so we'll talk about that just now. But it's basically, it shows you what you must do with the aircraft to get the desired situation that you have told the aircraft you want to be at. So whether that be climbing at a speed of 150 knots or pitching 10 degrees up, or maintaining a certain altitude, or whatever the case might be, you are telling the aircraft something, and the flight director is going to show you on the ADI what you must do to get to that a point that you've told the aircraft you want to be at. So here's an example of a flight director. Now there's a lot of information going on here, and I don't want you to get confused. So let's just focus on the most important thing. Let's focus on the ADI. So here's the ADI, the attitude director indicator. Here's your speed over here, right? The calibrated airspeed is over here. This is your altitude that you can see in the box over there. This is the tape, and this is the box. This is the airspeed tape, and this is the box, right? And you can see you can pre-select an airspeed, right? So you can set it to 175, and you can see the aircraft will maintain it. And then you can pre-select altitude as well. So you can see in this case they've set 1,400 foot as the altitude, and that is equal to 427 meters. And then your vertical speed indicator is here on the side. So this aircraft is obviously busy descending, and this is this aircraft's flight director, right? So you can see it looks a little bit different, and I'll show you the different variations just now. But this vertical line over here is telling you where you must move the nose to be on a specific heading, right? So if the vertical line moves to the right, it means you need to turn to the right. If the vertical line is moving to the left, it means you need to turn to the left. And wherever the vertical line is crossing the horizontal line, that's exactly where you want to put the nose of the aircraft. Right, and the nose of the aircraft is shown by this little white square over here. Right, these are the wings. These upside down L's, these are the wings, and this little white box, that is the nose of the aircraft. So I'm going to show you guys a few examples. Don't worry about it too much, but as long as you know that this is the flight director over here, this cross here. So let me give an example. Let's say we have gone from here. You can see we're roughly on a heading of 324. Let's say we select that we want to turn to a heading of 330. So we need to turn right. Now, as soon as you press that heading button and you set the heading to 330, right, there will be, you can't see it on this picture, but there's like a purple heading bug, we call it. You will turn that onto, obviously, a heading of 330. So that purple bug will be sitting here at the top. Okay, and then the flight director would command you to turn right. So what would it look like if you've done it? So if you've pressed heading mode on the autopilot controller, so you've selected heading, and the flight director is on like it is over here, and you've set the heading bug to 330, well, it's going to show you that. You can see, obviously, it's not going to be showing here anymore, right? So that's why I've made it more, let's call it more darker, right? Like a different pink. So you can forget about this one in the middle. It's just going to move to the right. Okay, and that means now you have to turn the wings of the aircraft to start turning to the right. And as you turn to the right, what's going to happen with that vertical line? It's going to do this, right? It's going to start moving in. So from where you've selected heading 330, if you turn to the right, it's going to start moving in until you're perfectly lined up with it again. Then you make a wings level, and then you should be on a heading of 330. Okay, so that is what the flight director does. Now, obviously, that is the lateral mode, right? So it's a vertical line, but it's showing you lateral deviations. So it's telling you where to turn your nose to. Now, obviously, we have something that can help us with vertical deviation as well. So let's say, for instance, as an example, you're flying 175 knots now, right? Let's say you want to fly 140 knots. So we've picked 140 knots. So you would set 140 there at the top, using the speed mode. Let me just go back here to show you this. Actually, it will be much better. So if we go here, right, let me see, speed, there's speed mode, right? Let's say you go speed mode, and then you put there 140. So you use this button and you put 140 there. Now the flight director is going to show you what must you do to fly at 140 knots. Now guys, remember, here you're still flying by hand, right? We haven't put the autopilot on yet. The autopilot is off, so you can literally pick, certain settings, and you can just hand fly the aircraft into the flight director, and the flight director will show you where, what you must do to be where you want to be. So if you want to fly 140 knots, it's going to show you what you must do with the aircraft to get to 140 knots, right? So okay, so there we are, right? 175 knots, and we want to go to 140 knots. So you will see if you've selected 140, it will say it there at the top. So can you see what happens with a bar? This horizontal bar will disappear from this position, and it will go and sit there right at the top. Because why? You're flying at a 175 speed, and you want to be at 140. So obviously you need to bring the nose up. So all you do is you take this square, and you can put it where these two bars are crossing. You don't have to turn or anything, you just bring the nose up. And as you take the nose up and you start pitching up, what will happen with the bar? It will move down and down until you're right on it. Okay, so, and then obviously you will be at 140 knots. I couldn't move that obviously, right? But you get the idea. Initially it would be right at the top, and as you pitch up, the bar will come down until you are sitting with the square right on the bar, and then you just keep it there. And then if you, for instance, have brought the nose up too far, well, the bar would start going down again, and that means you must lower your nose, because otherwise you'll be flying too slow, right? You'll be flying below 140 then. So the bar will always show you how to fly 140. That's what the flight director does. Now, guys, why spend so much time on this? You're most probably going to get, examples of this in the exam, right? You need to understand how the flight director works. So this is a very good example of one, and this actually comes from the annex. So you can see this bar is far to the left and this one is far down. And all you need to do is you need to understand if the bar is to the left of your aircraft and down, it means fly left and down. You want to go to where it is crossing. So you want to take that square there and you want to put it where the aircraft, where the two lines are crossing here. So obviously that's going to mean do a left hand turn and pitch down, right? And you can see here the aircraft is banking to the right again. So what is going to happen here? Well, we have a line that's to the left again, and now the bar is at the top. Okay, so that means we have to take this square and we have to put it there. So that means we have to make wings level or turn a little bit to the left because the bar is saying come to the left. And also we have the horizontal bar there, which says you need to pitch up. So you must probably flying too fast. You've selected, it looks like you've selected a speed in this case of 155 knots. You're flying 185, right? So you're 30 knots too fast. So obviously the bar is going to tell you to pitch up, right, until you get to 155 knots. So that's how the flight director works. And this is on the ADI, on the attitude director indicator. Now, I've shown you the crosses, right? These are the crosses. These are also a type of flight director, right, is the crosses. And you also get the bat wings or the V-bars. Now, this is typically on the Honeywell systems that you get this. So you can see here the green part is your aircraft, and then the purple parts are your flight directors, right? So this is now your flight director. You don't have a cross like this. Okay, and this can actually be changed. Once again, you can go pick, do you want a cross or do you want it like this, right? So some people prefer to fly it like this, some people prefer to fly it with a cross, right? All changes from pilot to pilot. Now, how does this work? Well, I've taken blue as the green. Okay, so the green is your aircraft, I've taken it as blue, right? So blue is your aircraft. If your flight director bars are like this, what does it mean? Well, you need to pitch up. You don't have to bank at all, because if you just take the triangle into the bars, well, the triangle is going to be sitting there. You don't have to bank at all. Over here, there's your aircraft and the bars are showing down, right? So you just need to pitch down and put the triangle into the bars over here. In this case, well, the bars are up, so it's away from you and it's banking right. So you have to pitch up and bank to the right. So just see yourself putting this triangle in that position over there. And you can see it's banking to the right and it's a little bit up. And in this case, there's the aircraft's nose. Now the bars are showing, the bat wings are showing that you must go down and to the left. So once again, imagine yourself putting the triangle in the bars over here. So this is what it's going to look like. Right, you can see we've pitched the first picture, we've pitched up and we haven't banked, right? The second picture, we have pitched down and we haven't banked, right? So just from that position down into the bars. And then the third picture, well, we were wings level and we were in this nose attitude, and then we have to go up, so we have to bank to the right. And then this one has obviously gone from wings level and pitching quite high up. Now we need to pitch down and bank to the left, so we put the aircraft into the bars. So pitching down and banking left. Okay, actually very straightforward. Guys, you can expect something like this in the exam, right? So make sure that you understand this, and this is really straightforward to understand. So on the attitude director, we also get the radio altitude, right? So on the ADI, we can also get our radio altitude, and this is displayed when the aircraft is at or below 2,500 foot above ground level. Okay, not above sea, above ground level. So the radio altitude gives you your altitude or your height above ground level. And then there's also decision height that can be displayed on the ADI, and this is displayed from 1,000 foot to touchdown. So if you're doing, for instance, an ILS approach, depending on the airport that you're flying to, there will be a decision height where you need to decide, are you going around or landing? Now let's say that is 200 foot as an example. Then you would put your decision height as 200 foot on the ADI. So there's a little knob that you can turn and you set 200 foot. Okay, and then your decision height is starting to display from 1,000 foot to touchdown, right? So when you approach 1,000 foot above ground until where you touch down, then it shows you your decision height. So initially when you're cruising at 35,000 foot and you put in your decision height before you start the descent, it's going to show while you twist the knob and put it in, and then after a few minutes it'll disappear, because it only starts becoming active when you are 1,000 foot above, right? It's just to keep your screen clear and not with a lot of clutter of information. And then let's say you've set your decision height at 100 foot, right? At 50 foot above the decision height, an aural alert chime sounds at an increasing rate until reaching the DH, right? So if you set it to 100 foot above ground, well, then at 150 foot, the aircraft is going to start talking with you, right? And you must probably have heard this 50, 40, 30, 20, or something like that, right? Or it would say 50 above, 40 above, 30 above, right? Something like this. Or it might just make a chime, right? Like a tree, okay? Something like that. So the RA ring and the scale changes from white to amber, and the DH marker changes from magenta to amber. So the radio altitude ring will change from a white color to an amber color, that's like orange, and the decision height marker changes from magenta to amber. So let me show you that. So this is typically on the Boeing 737 that you see this, and then the radio altitude will be shown over here. So that's 2460. That means that you're 2,460 foot above ground. Okay, and then the DH will be showing at the below the radio altimeter, right? So you can see you've set DH is 100. That means that at 100 foot above ground, you are going to make a decision whether you're going to land or whether you're going to go around. Now, when you get to 150 foot, these are going to change, right? They're going to go from white and magenta into amber. So that's what's going to happen. So at 150 foot on the radio altimeter, it's going to go amber. And also at 150 foot on the radio altimeter, the DH will also go into amber. And then it will start, the aircraft will start talking with you, right? Or it might just make a chime. So that is the radio altimeter and the DH. And you can see that is also indicated on your PFD, right? On your ADI. Now the HSI. There are different displays, right, for the HSI. So this is now the bottom screen, guys. Okay, so this is the screen that is below the ADI. So it's got different displays. Now using the MCP, the mode control panel, the pilot can toggle between different modes or settings on the HSI. And the ones that are mostly used is map mode, right? So like I've said, you can change all the settings on that HSI, right? So let's discuss a few different modes. Now the first thing I want to show you is the picture that you might see of the MCP, right? The MCP is the mode control panel. Like I've said to you, I've shown you one of a 747, right? This is just a generic one, but you can see it comes down to the same thing. It says HSI, then you've got map mode, center map mode, plan mode, nav full mode, VOR or ILS full mode, nav expanded mode, and VOR ILS expanded mode, right? These are all the different settings that you can toggle through when it comes to the HSI. So it just displays information to you differently. That's all it does. So here's an example. And please make sure that you know these. This is really important. Okay, so full VOR mode is this example over here. Okay, how do I know it's VOR? Well, because I see there's no glide slope on the side. Remember, an ILS has got a glide slope. It gives you vertical guidance as well as lateral guidance, right? So full VOR mode, you can see there's the HSI and you can see the little dots there. And how do I know it's full? Well, you can see the whole VOR instrument. That's what's called full VOR mode. So it's VOR mode because it doesn't have a glide slope. And it's full VOR mode because you can see the full VOR. Then you've got expanded VOR mode. Okay, now what is the difference? Well, it still shows you the VOR and the triangle as the aircraft. You can see there's the line of the VOR, there's the dots, right? In this case, we've only got 2 dots on each side, right? And you guys know by now that 10 degrees is full deflection. So obviously each of these dots are 5 degrees, right? So this is the expanded VOR mode. So can you see that they literally just zoom into that part of the VOR, right? You can see there's the circle, right, for that top part. And then your VOR is shown over here, and you can see some of your track, and that over there is typically weather, right? So you might have weather that is overlaid on your VOR. Okay, so this is called expanded VOR mode, right? And then the bottom one is called your map mode, and this is the one that you use most of the time. So in map mode, you'll see VOR instruments or VOR beacons. You will also see your routing, right? You can see there's a routing like that with the different waypoints that you're flying to. You can see your current track, and you can see the planned track, right? So that dotted line over there is your current track. That's where you're actually flying to. So that is map mode. It basically just shows you a map, right, with the different features on the map. And then you get plan mode. Now plan mode is purely just the plan that you are going to fly, right? This is like your flight plan. It doesn't show you all the VOR things and, you know, all those unnecessary things that the map mode is showing you. Plan mode just shows you your track or your flight plan. Then full ILS mode is almost the same as full VOR, but look at the difference on the side, right? So this is full ILS mode. That is full VOR mode. ILS mode, you've got these indicators on the side for the glide slope. Okay, and then you get your expanded ILS mode. So it's the same as the VOR scenario, but in the expanded ILS mode, you've got your localizer showing there, like it is over here, and then your glide slope over here, and then you can basically see a bit of a map as well, right, with the weather overlaid over there. So guys, it all depends on, I mean, it changes from company to company, it changes from pilot to pilot, right, on how you want to set these things. Just make sure that you know how, you know, each of the pictures look like, because that might be asked in the exam. Okay, so, and make it easy for yourself. Now these are pictures that is just in color, right? These ones were black and white, and these ones are in color. And the first one is center map mode. Now what is center map mode? Well, you can see the aircraft is in the center and it's a map. Okay, how do I know it's a map? Well, I can see different reporting points. It says, what does it say there? MCOL, Booser, Avalon or Amlon, right? And that's the track that you're going to fly, and you can see your headings there at the top. Right, so this is center map mode because the aircraft is in the center of the map. Then you've got plan mode. It's the same as the previous plan mode. This plan mode, see here, you had your lines there of your plan that you're going to fly and your different waypoints. Well, the same goes here. It's waypoints and your plan, right? It's plan mode. Then full VOR mode. Well, there we go. You don't have a glide slope, so you can see it's full VOR mode. This is expanded VOR mode. How do I know that? Well, I can see the dots over here again, same as over here, right? So it's dots over here for the VOR, but now it is just expanded. It's like it's zoomed in over here. So expanded mode is like the map mode, or yeah, the map mode, not necessarily the center map mode, but map mode like this, you know, with the VOR information on it. Okay, and then you've got two different types of map modes here, and you can actually set the range for the map, right, depending on how much of your routing you want to see. So you can see this range. There's the 5 nautical mile line. So this will be 2.5, 5, 7.5, and then that line there will be 10. So this is map mode, and the range is 10 nautical miles. It's only in map mode, guys, that you can set your range. Okay, that's really important. And then here's another map mode, but this is 5, 10, 15, 20, right? So the range over here is set to 20. Okay, and you can see these indications that you see over here. These are other aircraft. This is called TCAS, Traffic Collision and Avoidance System. There's another one over there, and it shows you -20. That means that this aircraft is 2,000 foot below your current altitude. This one is -25, so that means it's 2,500 foot below your current altitude, right? This is map mode. Make sure you know them for the exam. Now, as you can see, there is a lot of color symbology, right? I mean, just look at this picture over here. Okay, so I'm going to go through these really quickly. I would suggest that you know them as well for the exam. Green color symbology means it's engaged flight modes, and it's also dynamic conditions, right? So these are the things that you're busy using. Green always means you're busy using it or it is active. Okay, white is present status situation, scales, and armed flight mode display. So these are modes that you've selected on the autopilot or on the flight director that is busy running in the background. Like for instance, let's say you're busy intercepting a VOR. Now you've set the aircraft on a specific heading and you're going to intercept the VOR. Okay, then you're going to use nav function on the autopilot to intercept it. You don't have to know about all these things, I'm just mentioning it. So if you press nav, well, the aircraft is not necessarily going to turn straight away for the VOR. It's going to wait until the VOR is actually live and until you are on track to be able to intercept that radial. Okay, so therefore nav will be armed white. So heading will be green and nav mode will be white because it's running in the background. The aircraft knows that as soon as it's ready to intercept the radial, then it must do so. Okay, that's an example of a white color symbol. Magenta is purple. That's command information, right? That's like saying, I want to fly to this, or I want to fly at this speed, or at this altitude, right? And then cyan, that's blue. That's non-active and background information. And then red is obviously a warning, like always. And then amber is your orange, right? This shows you a caution, or it shows you faults and flags. And then black, if you see any black things on the screen, well, that's just like blank areas or an off condition, right? So like when something is put off, let's say you're not using the flight director or whatever the case might be, it might be displayed, you know, as FD and it's written in black, right? So here's an example with all those different color symbologies. Now this can obviously be very overwhelming, right? But you can see green is all your things that you're using currently, right? So these are all the flap settings, your QNH that you're using or QFE that you're using. You can see the autopilot is using heading select mode at the moment, and the white, look here, this is exactly what I was telling you, right? If you use nav mode, it says VOR lock as white. That means it's in the background, so it's waiting to intercept a VOR localizer or a radial, but at the moment you're flying on heading mode. And anything red is warning, right? Like pull up, you're going to fly into the ground. And then purple is your fly to status. So like for instance over here, this would be like 10,000 foot. That means that you have set 10,000 foot and you want the aircraft to climb to 10,000 foot. You've set 100 knots, you want the aircraft to climb to 100 knots. What else is there? Well, white is just like status message or background information. That's like your ground speed, for instance, right? You can see GS 92, meaning your ground speed is 92 knots. Yeah, here's inches of mercury. This is QNH, also in the background, 29.92. So obviously, I mean, at this stage, you're using 1013. That's why it's green, right? Over here, you can see in the background, 29.92 is your QNH in inches of mercury. Right, so that's just an example. And then you can see caution as well, right? It says your MAG. So there's obviously this might be displayed. I'm not 100% sure, but this might be displayed when there is an issue between the magnetic heading of this PFD compared to the co-pilot's PFD. Or if this is the co-pilot's PFD, there might be an issue, you know, with a heading comparison between this one and the captain's PFD. That's why it might show you a MAG there. And the reason for that is it picks up the difference, right? And obviously you can see it is amber. It's orange, so that's like a caution message. So let's talk about the flight management system. That was the EFIS. Now we've just touched on the flight management system as a part of the EFIS, right? I've just shown you guys now we've talked in a lot of detail about the two instruments, the ADI and the HSI, right? That's really important to understand. You need to understand what is a flight director. You need to understand what is the HSI, the mode control panel, you know, how all those different things work, right? So now the flight management system is just a component of the EFIS. Not a component actually, it's just something that can be linked with the EFIS, right? So this acts like the brain of the aircraft. The FMS is acting of the brain. It carries all the information and databases and is responsible for making calculations, guys. So this is like the thing, you put information in there and this thing calculates everything for you. I mean, you put in there that you want to fly from Cape Town to Johannesburg at 30,000 foot. You put in the weather there. You put in the runway that they're using at the airport that you're taking off from, so like Cape Town, right? And this thing will calculate everything. It will tell you how much fuel you're going to burn, what is the best altitude to fly at, what is the flight time going to be, what is your ground speed going to be, all those things, right? It's a very, very powerful system. And it's basically got 4 components. So the flight management system itself has got 4 components. And these 4 components are the flight management computer system, so the FMCS, that's the computer itself. Then you get the autopilot or the flight director system. Then you get the auto throttle and the inertial reference system. Now, like I've said to you, for now, don't worry about the inertial reference system too much. Now, the auto throttle, what is that? I've touched on it earlier as well. The auto throttle system is where, you know, you've basically got like autopilot on your throttles. So you can put the auto throttle on and you can tell the aircraft fly at 120 knots and the aircraft will automatically adjust the throttles for you to fly at 120 knots. Okay, and the flight management system can actually, it's capable of doing 4-dimensional navigation. So that's latitude, longitude, so north, south, east, west, right? It can do altitude and also time, right? That's why it's called 4-dimensional navigation. So it's got 4 things, latitude, longitude, altitude, and time as well, right? And then, why do we have the flight management system? Why do we need, why don't we sit the night before and, you know, go and calculate the fuel that we need and plot our top of climbs and top of descents and all these things? Well, as you can imagine, this helps with economy and pilot workload. So the FMS acts as either a primary controller or just as an advisory for the pilot. So for instance, speed bugs and RPM bugs. Now, what I mean here is that it helps with economy and pilot workload. Can you imagine that if you need to fly the aircraft at 120 knots constantly, if you're flying in you know, really windy conditions, you're going to play with those throttles quite a lot, right? You're going to have to really play with the throttles to maintain 120, and you're most probably going to fly 125, 130, and then 115, and then 120, and then 125 again, right? You're going to be jumping all the time. If you put on the auto throttle, the chances of that thing maintaining 120 knots and using the power with very small movements is much higher and much more economical than what you can do as a human. So these systems are more economical than a human. And as you can imagine, it helps with pilot workload. If you can tell the aircraft fly at 120 knots and it works everything for you, you can literally sit and manage. You watch the speed, you watch the altitude, and you manage the aircraft. That makes it more economical, makes it more safe, and it takes a lot of workload off you so that you're not so fatigued. Now the FMS can either act as a primary controller, so it can be the primary thing that's controlling the aircraft, right? So you literally give all authority to it and you just watch it, or it can be just as an advisory for you, right? So, and an example of this is speed bugs and RPM bugs. Now what I mean with this is, let's say you have inserted into the FMS, right, into the computer, you have said that when you are taking off, you want to climb out at 150 knots. Now, what the aircraft will then do is, because you've told the computer that that is what you want to do, it will actually, on the speed tape, so on your airspeed indicator, it will give you a little speed bug, right, like a little indicator to show you this is where you want to fly, okay? And also, if it can give you an RPM bug as well, right, it can show you where you must put the power to actually fly at that speed, right? So if you've got too much power, well, let's say you're flying at 2,500 RPM, then the RPM bug will be sitting at 2,200 RPM as an example. So that means you have to reduce the power to 2,200. So this thing can literally, figure out everything for you. And that's what the basic architecture looks like. Now, I'm not going to get into a lot of detail, guys. You can just, study this from your notes, but you basically have the AFDS over here, which we've talked about, right? That's called the autopilot and the flight director system. That's the AFDS. Then you've got the auto throttle system over here, and then the IRS. The IRS, like I've said to you, don't worry about it too much, but it's the inertial reference system. And the inertial reference system is a system that works with gyroscopes. And with this system, it can pick up where you are in terms of latitude and longitude. So this is the system that literally gives navigation information to the computers, right? And here are the two. Usually I have two of these, sometimes only one, but these are called the FMC CDUs, so Flight Management Computers. So these are the computers itself, right? And CDU stands for Computer Display Unit. So I'm pretty sure you've seen these before, and you literally put in everything here, right? You from start to finish. So you put in your weight here, you put in your fuel, it gives you your zero fuel weight, you put in your reserves, you put in the runway that you're taking off from, the temperatures of the airport, all these things, and it literally calculates every single thing for you. So it's a really powerful computer. And whatever you've put in here, it will liaise that information to the autopilot, to the auto throttles, and also to the IRS. And these things can then talk back to the computer, right, to see whatever the computer has told them to do, whether they have done that, right? So these things are all interlinked, as you can see. That is basically the FMS system. And like I said, this is a system on its own. It's not part of the EFIS. This system can just be connected to the EFIS so that when the auto throttles are moving, for instance, you can see on your RPM or on your engine instruments on the EFIS that you are increasing RPM or decreasing RPM. So this thing can be connected with your electronic flight information system. So then everything can be displayed electronically. So let's talk about the flight director system. Now, I've already actually spoken quite a lot about it, and I've shown you the different things, and how it works. But the function of the flight director is it's able to combine information from various sources and display them as a series of pitch and roll commands, like you've seen, right? The cross or the bat wings. So it takes information that you give the aircraft. You tell the aircraft, I want to fly at 100 knots and on this heading. And the aircraft will tell the flight director, well, this is what this pilot wants to do. Show him how to do it, right? And then that is what the flight director will do. So what is the advantages of it? Well, it reduces the scan. Can you imagine you literally just look at your flight director and you follow exactly what it is saying you should do, and you're going to be flying perfectly on the numbers. So it simplifies the interpretation and removes the need for the flight crew to analyze the inputs before making the necessary control inputs. So instead of now having, let's say for instance, you want to climb to 10,000 foot at 120 knots. You're going to constantly have to scan. Are you flying at 120 knots? Are you still on your heading? When is 10,000 foot coming? Are you at 120 knots? Are you still on heading? When is 10,000 foot coming, right? So that scan. Now, all you have to do is you literally just look at the flight director system, and when you approach 10,000 foot, the flight director will automatically go down and show you have to lower the nose to level off at 10,000 foot. Or if you are veering off your speed and you're not flying at 120 knots, let's say you're starting to fly faster, the flight director will move up a little bit to show you bring your nose up to fly slower and maintain 120 knots, right? So you literally just have to watch those bars or those crosses and you will be flying perfectly on the numbers. Now the nice thing is you can either fly it manually like that, so you can literally control the aircraft and fly the flight director, or if you put the autopilot on, then the autopilot will fly the flight director for you. And that's how the two systems are interlinked. So the commands of the flight director are always monitored. Okay, the commands that the flight director gives are monitored to avoid overstressing the aircraft. Now let me give you an example of this. Let's say for instance you are flying on a heading of 360 and you want to turn onto a heading of 090. Okay, if you turn the heading bug and you set it to 090 and your arm heading mode, while the flight director will not show you to bank at 45 or 50 or 60 degrees, right? Even though it's a 90-degree turn, it will only stick to a rate 1 turn. And the same goes for if you want to, let's say you're flying at 100 knots and you want to fly at 160 knots, as an example, right? The flight director will not show you to pitch down 30 degrees. It's only going to show you pitch down 3 or 5 degrees, right? And then so basically it gives you, it helps you to make small inputs, right? It doesn't get you into a position where you're going to overstress the aircraft. So if you follow the flight director, it'll always show you to fly in the envelope of the aircraft. You'll never overstress the aircraft if you follow the flight director. And here are the basic control inputs, right? So here's the flight director itself. Now this is obviously the cross or the bat wings that I've shown you. And the flight director itself gets its inputs from quite a few things. Now, it gets its input from the compass system, which can be a preset or a current heading, right? So let's say you're flying on a heading 360 and you want to turn onto a heading of 010, so you want to turn right a little bit. Well, then you're going to use the heading bug, you're going to set it on 010. Then it's going to send that information to the roll channel. The roll channel is the channel that is responsible, and this is part, by the way, of the flight director computer, so the FD computer. And this roll channel then tells the aircraft, okay, we need to roll right. This guy wants to turn onto a heading of 010. Okay, so then the aircraft rolls to the right, and then it makes wings level on heading 010. Because what happens is the roll channel, that's if the autopilot is obviously on. If you're flying manually, the roll channel will send the information to the flight director, and the flight director will show you turn right. Okay, so it'll bank to the right, and then you have to bank to the right, and as you're nearing heading 010, the flight director will start becoming level again. That means you have to make wings level, and then you fly wings level. Okay, so it gets information from the compass system. It can also get information from your localizer or your VOR radio, right? And that goes to the roll channel as well. This is for intercepting and flying radials. Goes to the roll channel, and that is shown on your flight director indicator. So either you can fly it manually, or if the autopilot is connected, it will follow the flight director commands. That is the compass system and your localizer or VOR radio. Then you get your vertical gyro unit. Now, the vertical gyro unit comprises of a roll gyro and also a pitch gyro, right? This is your AH, okay? So if you're rolling, for instance, that gets sent to the roll channel, and then that once again gets sent to the flight director indicator. So let me give a practical example. Let's say you want to maintain heading 010 now, and you look down to grab a bottle of water or something, and you roll a little bit to the right onto a heading of 020. Now obviously you're not on a heading of 010, and then the flight director must be able to show you, hey, you must turn back left, you want to be on a heading of 010. So how does that work? Well, it comes from the vertical gyro, so from your AH. So on the AH, the aircraft would sense that you're rolling to the right. Okay, so what does it do? It immediately sends that command that you're rolling to the right to the roll channel, and the roll channel will send a command to the flight director to show, hey, the flight director must move left because you're busy rolling to the right. You're moving off your heading of 010 to the right. Okay, that's how it works. And the same goes for pitch. right? So let's say, for instance, you want to maintain altitude. Let's take the same example. Let's say you look down to grab a bottle of water and suddenly you pitch the nose up a little bit. Now obviously you're going to leave your altitude then, right? You're not going to maintain it. So what's going to happen? Well, a pitch command is going to be sent to the pitch channel. So there are two channels in the flight director computer. It's the roll channel and the pitch channel, right? So from the pitch channel, it will get sent to the, from the pitch in the vertical gyro, so on your AH, it will pick up, hey, this guy is pitching up. So it will immediately send a signal to the pitch channel, and the pitch channel will interpret the signal and say, hey, you're pitching up, but you've said you want to maintain altitude. So what does the pitch channel do? It sends information to the flight director indicator to say, pitch down a little bit, show this guy to pitch back down, he needs to maintain altitude, right? And then it can also come from your glide path. So that's where you use the ILS once again, right? So obviously glide path information will get sent to the pitch channel, and that'll mean that obviously the pitch channel will make the necessary changes and send that to the flight director to show you what you must do to remain on that glide path of the ILS. And then also you need information from the air data computer. Now the ADC, or the air data computer, this is the computer where you get inputs from the airspeed indicator, from the altimeter, and from the vertical speed indicator, right? Because let's say you've told the aircraft you're going to fly at 120 knots, okay? Whether you might not be pitching or rolling, but you might have reduced the power. Then something needs to tell the flight director, hey, this guy's reduced power. You need to tell him, what he must do to maintain his 120 knots. Now, depending on the system that you've got, the aircraft can either tell you to add thrust, or the flight director will just show a little bit of a pitch down to show you, hey, you must start flying faster, depending on what you've selected. But you also need inputs from speed and altitude and vertical speed, and that will also go into the pitch channel, right? And if you like, for instance, flying slower than what you've told the aircraft you want to fly, well, it's going to see you're not flying at 120 knots, you're flying at 100 knots. It'll send that to the pitch channel. The pitch channel will work with that information and tell the flight director whatever it must do to show you how to get back to 120 knots, because you're flying at 100 knots. So guys, this is basically how the control inputs of the flight director look like. Now, how do they ask you this in the exam? Well, they won't ask you to draw something like this, obviously. You just need to understand the different channels and how the information gets to the flight director. This is to give you an overview so that you understand the bigger picture. Okay, so you need to understand the basics. You don't need to understand anything more than that. If you understand the basics, then you will be fine. So let's look at the modes of operation, because the flight director has different modes of operation. So what are these different modes? Well, depending on the stage of flight, certain modes will be used. So for instance, speed mode will be used in the climb. So you can tell the aircraft you want to climb at 140 knots. Or altitude hold mode will be in the cruise, right? So if you get to 20,000 foot, the aircraft must level off and it must maintain 20,000 foot. Then the flight director mode will be altitude hold mode, right? It must show you whatever you must do to hold altitude. So let's talk about using the flight director. Well, the flight director can be used when you are flying manually, but it will be engaged as soon as the autopilot is used. So you cannot use the autopilot without the flight director. So if you pick the autopilot selections and you put the autopilot on, it must use the flight director. That is the reference of the autopilot. It literally just follows the flight director. So it cannot operate without the flight director. And then the different modes that you get is attitude mode, heading mode, altitude mode, localizer VOR mode, glide slope mode, and then also your go around mode, right? Those are the different modes. So let's go through them. And guys, where you see this, and this is crucially important, this is flight director modes, right? That's called your FMA, right? Your flight mode annunciator panel, and that is at the top of your ADI. Now, what do you use? You use your control panel over here, right? The flight director control panel, or the autopilot control panel, if you want to call it that. You use this panel to select what modes you want to use. So now in our case, we've got attitude mode. In attitude mode, you literally just tell the aeroplane you want to fly at a fixed attitude. So you want to fly wings level and at 4 degrees, right? So you can see this, let me just see here, 2.55, 7.5, yeah, that looks like around 4 degrees pitch up, and you can see the wings are level, right? So the mode that you'll be in here is pitch mode and roll mode, right? Pitch and roll. That means that it will maintain this pitch over here, and it will maintain wings level like it is over here. That's why it's in roll mode. These are the basic modes of the flight director. Okay, if you don't select anything on the autopilot, like heading mode or approach mode or speed mode or whatever, and you just put the autopilot on, it's going to go automatically into these two modes, pitch and roll mode. Those are the basic modes. And also, if you let me just think how I'm going to say this. So these are the basic modes that the autopilot will always revert back to. So for instance, if you're trying to if you're trying to like have the aircraft fly, let me just think how I'm going to say this. If you give the aircraft two inputs on the autopilot panel, right, and it cannot comply with both the inputs, right, it will just revert to its basic modes, right. It will go back to pitch mode and roll mode, right. That's what what the autopilot will do. Or as an example, here's a good example. I've got one now. Sorry, I just had to take some time to think about it. But if you, for instance, you've told the aircraft you want to fly at 175 knots, right? So you took speed mode and you flew speed mode 175 knots. Now let's say you press that button, you take speed mode off. But the autopilot is still on, right? You've got a master switch for the autopilot. So if you deselect speed mode, it doesn't mean the autopilot's going to stop working. It's still going to, keep on flying. It's just not going to maintain that speed. But what is it going to go into? Well, it's going to go into pitch mode. Okay, because the autopilot doesn't know what to do, right? If you just take speed mode off and you've told it fly on this heading and fly at 175 knots. Now you don't tell it to fly at 175 knots, but it must stay on this heading because the autopilot is still on. Well, what is it going to fly at then, right? So then it reverts back to its basic mode, which is pitch mode. And then another example is just the opposite of that. Let's say once again, you tell the autopilot fly at 175 knots, so you use speed mode, and you use a heading of 3 to 4 degrees, right? And you tell it fly on a heading of 3 to 4. Well, so then that would say speed mode and that would say heading. And let's say you take heading mode off, right? So you just click heading, but the autopilot is still on. Then it's going to show there speed mode and you're going to fly at 175, but then it will revert back to roll mode over here because you've deselected heading mode. So as long as the autopilot is on, if you deselect any mode that you have selected, it's going to revert back to its basic modes, which is called the attitude mode. It's pitch mode and roll mode. It will literally just keep wings level and maintain the current pitch attitude that you are at. In this case, it's 4 degrees Celsius, 4 degrees. Then heading mode, so look at the commands, right? Pitch and roll, and remember this is your FMA, flight mode annunciator. Now let's say heading mode, right? So let's say we've selected a heading. So now you press heading there, and then it's going to show you you're on heading mode, right? So you can see your lateral indications are here and your vertical indications are here. So speed and pitch and things like that, and heading or nav or whatever will be on this side. Okay, that's heading mode. That's when you select a certain heading to fly to. Then altitude hold mode. As soon as you're holding altitude and then obviously heading as well, altitude mode will go green. That means it will maintain this altitude that it is currently at, or it will show alt when you have leveled off at the altitude that you have set there. So let me give an example. If you were in the descent like this aircraft is now, right? You can see it's descending here on the VSI. It's going down to 1,400 foot. It's passing through 2,680 foot roughly, right? When it gets to 1,400 foot, it will start showing alt because it will level off at 1,400 foot. In this scenario, as it is descending, it won't show alt. Alt will most probably be white, right? Alt will be white because altitude mode is armed. It's running in the background in the brain of the aircraft. But the one that will be active will most probably be vertical speed, or then depending on the selection, it can be speed mode as well. If you told it that you want to descend at 175 knots, well, then it's going to do that for you. Okay, so only when altitude is captured or when you want to maintain current altitude, then altitude mode will be shown there as green. Then localizer or VOR mode, well, that will show nav or lock, either or. Okay, so nav mode will be for VOR mode and lock will be for localizer. This is when you're flying an ILS, right? And when you've intercepted the ILS glide slope as well, it will change to lock and just glide slope. Okay, so if you're just flying a VOR, so you're intercepting a radial, for instance, you're going to use nav mode, right? Now you can see it doesn't show, let me just see here. Now it doesn't show you nav mode on this panel. Remember, like I've said to you guys, this changes from aircraft to aircraft as well, right? So typically you have a nav selection on the autopilot. So instead of lock, it must be nav, but you can clearly see in this case they use lock as nav as well. Okay, so you'll have nav for VOR mode, so that means that you're going to intercept the VOR on the autopilot in nav mode, and then if you're flying an ILS, it will show lock because it picks it up as a localizer. And then as soon as you've intercepted the glide slope and you start the descent on the ILS, then it will turn to glide slope as well. So altitude mode will turn into glide slope, right? That's glide slope mode. So those are all the different flight director modes. Oh, sorry, there's one more, go around mode. This is important. So go around mode is a switch here on the side of the throttle, right? Obviously this position of the switch can change. On some aircraft it's not on the side, but it can be sitting here, you know, somewhere closer, but it will be around the throttle, somewhere at the back here or on the front, depending on aircraft manufacturer. But you have a go around button, and if you press that button, what will happen is this vertical bar will just pitch up, right? Your flight director will pitch up. It will show you wings level, always wings level, and it will show you where to pitch the aircraft to go into the go around attitude. And it actually calculates this with your configuration in mind. So it knows that you've got gear down, that you've got a certain flap setting. All these things play a role when the flight director decides where it wants to put this bar over here. So you can literally just then pitch the nose up into that position, and then you will be in the correct go around attitude. And then you'll see it says GA in the pitching plane and roll in the lateral plane, right? So roll meaning it will keep wings level, and GA stands for go around, so that means that you're going to pitch the nose up to the go around attitude of the aircraft. So guys, that's it. Well done. Day 3 is completed. We're getting there, and we're almost done with this training module. So well done on completing day 3. Make sure that you understand the things that we've talked about now, that you go through those those pictures that I've shown you, and that you understand the architecture of the EFIS and of the FMS. That's really important for the exam. And then, as you should know by now, make sure you practice those questions, and that you go through your notes, study the things you have to study. Stick to the syllabus, guys. Just study whatever is in the syllabus, nothing more, nothing less. So then I'll see you in day 4. Thanks for watching.